In this video, we're going to be going over chemical reactions and also energy changes. And the two different reactions that we're going to talk about are exothermic and endothermic reactions. And this is our part 4 video inside of chemistry, chapter 3. So let's get started with this video. So starting off, we're going to look at some examples of energy and chemical reactions, and then later on, we're going to talk about endothermic and exothermic reactions. So in this case, energy and chemical reactions, an example of this is plants. So plants are all around us. They can be found outside, inside our homes, and basically plants go through chemical reactions by the process of photosynthesis. So plants use photosynthesis as an energy absorbing reaction. So basically what they do is take energy from the sun and they absorb that energy. So during photosynthesis, plants convert carbon dioxide and also water into glucose and oxygen, which they store inside of their cells, and they do this with the energy provided by sunlight. And without light from the sun, plants actually cannot perform photosynthesis and will eventually die out because they cannot produce food. So this is our first example of photosynthesis, and then later on we're going to see how this relates to endothermic and also exothermic. And moving on to our second example, we're going to talk about cellular respiration. So cellular respiration is basically just the reverse process of photosynthesis. So inside of photosynthesis, the plants were basically just absorbing light, and inside of cellular respiration, it's the exact opposite. So this process of cellular respiration occurs in plants and also animals, converting glucose and oxygen back into carbon dioxide and water. So in this case, plants and animals basically just release carbon dioxide. So inside of photosynthesis, it was a process of absorbing, and inside of cellular respiration, it was a process of releasing. And in this case, plants and also animals take place. So inside of plants, specifically, basically plants, once they're done with photosynthesis, they have the glucose and oxygen in their cells. So what they do is that they use cellular respiration to spread around this glucose all around. And basically that energy and glucose that is stored is for the organism's use. And then basically what they do is that they use that glucose for their own personal growth and everything else. So now we're going to talk about endothermic reactions. So basically some reactions require continuous energy input to occur, which is absorbed by the reactant. And these are called endothermic reactions. And a primary example of endothermic reaction is cooking food. So basically what endothermic is, if we look at this picture here, endothermic is a process of absorbing energy, and then that energy is used to do something else. So in this case, if we're cooking or we're trying to boil water, so what we need to do is put the cooking pot on the stove, and then once we turn that stove on, that is the process of endothermic. The pan is absorbing that energy from the stove. So if we go back to our example of photosynthesis, photosynthesis was a process of where plants were absorbing the energy from the sun. So photosynthesis is an example of endothermic reactions. So in conclusion, endothermic reactions is the process of absorbing energy. And now we're going to talk about exothermic reactions. And basically exothermic reactions are just the opposite of endothermic reactions. So endothermic reactions was the process of absorbing, and then exothermic is the process of releasing. So reactants basically just release energy, often in the form of either heat or otherwise known as thermal energy, and this is the process of exothermic reactions. And some examples of exothermic reactions include cellular respiration, explosions, combustion of gasoline in engines, rusting of iron, and there's many more. So if we go back to the example of cellular respiration, since we're releasing carbon dioxide, that is the process of an exothermic reaction. And some other examples, if we were to look at this picture here, we can see that there's a bomb that is being exploded. That is an example of exothermic reaction as energy is being released. Another one could be when you turn on the heater inside your car, that's also an exothermic reaction. And there's many more different examples of exothermic reactions as well. So now moving on, we're going to talk about the difference between chemical change and also physical changes. So not all changes involve energy as chemical changes. They can also be physical changes as well. And some examples of this is melting ice, which is endothermic. And inside of melting ice, there is no actual chemical change that occurs. It's just a simple process of change in state of matter. And then inside of evaporation of water, it's also endothermic, and then condensation of steam is exothermic. So basically here we're saying that exothermic and endothermic reactions can also occur in physical changes as well, not only chemical changes. And in order to determine if a chemical or physical change has occurred, we can ask some of the following questions. So for the first question, does the substance change in composition or just a change in form? So if there is a change in form, then we know that it would be a physical change, such as melting ice. It's just a change in form. It went from a solid to a liquid. For the second question, can the original substance be recovered by simple physical means? So if the original substance can be recovered, then we know that it's a physical change, and if not, then that means it's a chemical change. And are there new substances with different properties produced? And if there are new substances with different properties, then we know that there is a chemical change. And is the change reversible by simple physical means? And if it is reversible by simple physical means, then we know that that would be a physical change. And if it wasn't able to be simply reversible, then that means it's a chemical change. So this is the difference between chemical and physical changes. And now we're going to talk about the law of conservation of energy. And this fundamental law basically just says that energy can be transformed from one form to another form without being created or destroyed. So basically, energy cannot be created or destroyed, and it can only be transferred. And the total energy of the universe remains constant. So that means that the total energy inside of the whole universe is always constant. And an example of this is potential chemical energy stored in the bonds of substances is often converted into thermal energy or light. So basically, if we were to have something and then the potential energy would be stored inside of that bond. So that bond has potential energy there. And then once something is to poke it, then it's going to convert that potential energy into thermal energy or even light. And the same thing applies with the universe. It looks like it's rapidly expanding. However, there's a bunch of potential energy out there, and then once that potential energy gets poked or provoked by something, then it's going to expand. And that case is just a conversion of energy and transformed. It's not actually being created or destroyed. And here's a common misconception of the law that we just stated. So a common misconception is that it seems that energy is being created, as in the burning of woods, which releases heat. If we can look at this picture here, we can see that there's a wood burning. So once it's burning, then it's releasing heat. So in this case, it looks like energy is being created. However, the correction of the misconception, the conclusion is inaccurate because it fails to recognize that energy is actually being released during burning, and it was initially stored inside of the wood as chemical potential energy. And then when that wood burns, then that stored energy is released as heat and light. So as we were seeing in the last slide, there was just potential energy is stored inside that wood, and then it got provoked by the fire, and then that's when it got transferred into heat and light. So this covers the common misconception. And now for breaking and forming bonds. So breaking and forming bonds, energy is required to break chemical bonds and reactants, and energy is released when new bonds are formed in the products. So when bonds actually break, energy is required inside of the reactants, and then once new bonds are formed, then energy gets released. So in this case, if we look at the examples, if we relate this back to endothermic and exothermic, for the endothermic process, the breaking of chemical bonds requires an input of energy, making it an endothermic process. So in this case, if we're trying to break a bond, then it requires an input of energy. And if we're inputting energy, that's basically just absorbing energy, and which makes it an endothermic process. So inside of endothermic reactions, basically if a reaction requires more energy to break bonds than it is to form new bonds, then it is endothermic. So inside of the reactant side, if we look at this example, inside of the reactants, if there is more energy to break the bonds than there is to be releasing, then it would be an endothermic reaction. So in this case, we're using energy and water, and then once those two are combined, then we're basically breaking that water down into hydrogen gas and also oxygen gas. So in this case, this is an endothermic reaction because we're breaking the bond. And now for the opposite, we're going to talk about the exothermic. So for an endothermic process, the formation of new chemical bond releases energy, making it an exothermic process. So exothermic is the process of forming of new chemical bonds. And in this case, if a reaction requires less energy to break and then more energy to release, then it is exothermic. So if there's more energy required to release, then it would be exothermic. As in this case, we can see in the product side, there is energy plus water, So that means then that this would be exothermic because there's more energy trying to be released than to form. So in this case, it'd be hydrogen gas plus oxygen gas is equal to energy plus water. And for a summary of this video, we talked about exothermic reactions, evidence of chemical reactions, and also endothermic reactions. So that summarizes everything for this video. Thank you so much for watching from Try to Be Useful, and we'll see you in our next chemistry video.